the main topic that we have is the questions with a situation like this, in which we have a wall or a ladder and a wire or a string is connected to the wall or the ladder to a certain point. So let us start off with the first one. A rod PQ is attached at P to a vertical wall as shown in figure 3.1, and then you can see the diagram as well. The length of the rod is 1.60 meters. The weight of the rod acts, everything that they have explained is already given in the diagram. So whatever is given in the diagram is just the description of it. So I'm moving on to the first part, that is part A, determine. And the next sub part of it is the vertical component of force F. So where is your force F? This is your force F. So you need to resolve this force into perpendicular components, and out of those two components you need to find the value of the vertical component. So once again, this is something that we already studied in chapter number 1, where we study the resolution of vector into perpendicular components. So you have this force F, which is top left corner. So you can draw one of the component upward and one of the component towards the left side, and the component upward would be your vertical component. And you know this thing we explained previously, that the component that is there directly with the angle is cos theta times the vector. So you would be F cos theta, and the upper one, the vertical one, would be F sin theta. So F cos theta is the horizontal one, and F sin theta is the vertical one. So the vertical component is F sin theta. We represent the vertical component of the force F by Fy. Fy means the vertical component of the force F. Now what is the value of F? It is given in the question that the force F is 44 newtons. So we write 44 here. Now how much angle is given? Theta is 30 degrees. So 44 times sine 30. Sine 30 is 0.5, so 44 times 0.5 would be 22. Multiply by 0.5, the number is reduced to half, or you can just hit it on the calculator. Then the next part is find the horizontal component of F. So like I said, the horizontal component in that situation is represented by Fx, and that equals to F times cos theta. So F was 44, cos 30. Cos 30 is 0.87, and you multiply by 44, so you'll be getting 38. In 2SF you'll be getting 38. Then you have the next part. By taking moments about point P, determine the weight of the rod. So we need to find the weight of the rod, and the pivot is point P. So let's go to the diagram first. This is your pivot, around which or about which we need to apply the principle of moment. And we have chosen the pivot as well. The next thing that we can do is check out how many forces do we have, and which one of the forces would rotate the rod clockwise, and which one of those would rotate the rod anti-clockwise. So here we have the force W, which is from the right side. It is pushing the rod downward, so the rod would rotate clockwise. You can write CW with it, or just write C with it, clockwise. Then you have the force F, but you see the force F is making some angle with the distance. Whenever the force is making some angle other than 90 degree with the distance, we can resolve the force into components. We can resolve the distance as well, but here we are resolving the force. So we resolve the force into two perpendicular components. One of them was F cos theta, and the other one was f sine theta. And the direction of the distance or displacement is this thing, horizontal. And we have to choose the component of force that is perpendicular to the distance. And that component of force is f sine theta. So you can see over here, we are having an angle of 90 degrees with the force and the distance here, perpendicular distance from the pivot. So one of the force that is responsible for moment of force is W, and the other force that is responsible for anti-clockwise moment of force would be f sine theta. And how much was f sine theta? It was 22. Force is W, and the other one force is 22 Newton. Let us now apply the principle of moment. So the clockwise moment would be W times the perpendicular distance of that force W from the pivot is 0.64. Okay, given over here. So W times 0.64. That's all from the clockwise. And from the counterclockwise or anti-clockwise, what do we have? We have the force of 22 times the perpendicular distance of that force from the pivot. How much is that? Well, you can add these two. You can add 0.64 and 0.96. You'll be getting the total distance of that force from the pivot. So what do we get? 22 times 1.6. From there, you can find the value of W. Just hit it on the calculator, and the value of W would be 55. For the part C, we have the question, explain why the wall must exert a force on the rod P. So let's take a look at the diagram. You see, one of the component of this force is F cos theta. And F cos theta is the force that the rod is applying to the wall at the point P. Because you see, the direction of F cos theta is towards the left side, which is a force that is pressing the wall. As consequence, as a reaction, the wall would exert the same force back onto the rod in accordance with Newton's third law of motion. F cos theta, which is one of the component of force F, pushes the rod into the wall, because that component of the force is directed towards the left side, which is towards the wall. Now, in accordance with Newton's third law, the wall would also exert the same force, but in opposite direction, on the rod at point P. Then we have the last one on figure 3.1. Draw an arrow to represent the forces acting on the rod at P. Label your arrow with the letter S. So in this situation, like we explained this case previously, I explained this one, that the force that would be exerted at this point would be directed over here. Okay, so let's move on to the next one. State the two conditions for an object to be in equilibrium. Alright, so the first condition is there should be no net force in any direction, means all the forces should be balanced. And the second condition is there should be no net moment of force about any point. So it means if you take any point as a pivot, then the sum of clockwise moments and the anti-clockwise moments about that point should be equal. However, the description is, you can see the same thing on the diagram as well, so I'm not going to read the description. Let's move on to the first part. Calculate the vertical component of the force exerted by the rod on the beam. So what is the force exerted by the rod on the beam? You have this one, 33 Newton. You need to split it into perpendicular components, and then you need to find the value of vertical component. So one of the component would be, you can draw it in this direction towards right side. So the force, you can see the direction of this force is top right corner. So one of the component is upward and the other component is towards the right side. Which one of these two components is the vertical one? This one. And let's check out the angles. You see, this angle is 52. Thereby this angle would also be 52 degrees. All right, alternate angles. You see, every time you see a Z, like over here, you can see a Z. So these two angles would be equal. We studied that in mathematics. Now the component of the force or component of the vector that is directly with the angle is the x component. You write it as 33 times cos theta, which in this case would be cos 52. And the other one would be 33 times sine 52. So the vertical component is 33 times sine 52. So I'm going to write here 33 times sine 52. Then you hit it on the calculator and you'll be getting 26 for this one. 26 newtons. And the answer has to be less than the actual vector. The actual force was 33 and the answer has to be less than that. Then we have the next question for 3 marks. By taking moments about point A, calculate the weight of the beam. So we need to find the value of W, which is the weight of the beam, and we need to consider the point A as the pivot. So where is the point A? Let me find the point A. Okay, so this is your point A, this is your pivot. Okay, this is your pivot. And what you need to find is, you need to find the value of this force, which is W. So let us first label the forces that would be producing the moment of force. So we have one of the force as W, which obviously we need to find. Then we were having a force of 33 Newton, but that force is not perpendicular with the distance from the pivot. We have a component of that force which is perpendicular, and that component is 33 sine 52, which is, I'm going to write the value now, 26. So instead of this one, I raise it off and I write 26 here. So that force 26 Newton, which is a component of the force 33 Newton, this force would be responsible for the moment of force. So we're going to highlight this one. Then what is the next force that is going to produce the moment of force? That is the weight of the bucket, and that force is 12 Newton. So 3 forces are there. W, force of 26 Newton, which is a component of the force 33 Newton. And the last one is the force of 12 Newton, which is the weight of the bucket, weight of the empty bucket. Now let's check out which 3 of these forces would produce clockwise moment, and which of these 3 would produce anti-clockwise moment. So this one would push the rod over here, this one would produce clockwise, W would produce clockwise, the bucket would produce clockwise, and the force of 26 Newton would produce anti-clockwise. Now let us apply the principle of moment. So the first one, clockwise, is W times the perpendicular distance of that force from pivot. Now what do we have? Let me check the beam is of the length 0.40, and is that a uniform beam? Yeah, uniform beam. So we can see over here it is a uniform beam. Uniform beam means the center of gravity would be exactly in the middle. So what is the total length of the beam? 0.40, and the center of gravity would be at the point 0.2. So we write here 0.20 equals, not equals because we have another force that is going to rotate it clockwise. So plus, what is that force? 12. And what is the perpendicular distance of that force from the pivot? All of it. 0.3 plus 0.10, which is 0.4. So times 0.4. 12 times 0.4 equals the counterclockwise moment. There's only a single force that is going to produce a counterclockwise moment, that is 26 Newton. So 26 times how much is the distance of that force, perpendicular distance of that force from the pivot. It is this much, which is 0.30. So we write 0.30 here. So what you do is find the value of this one, find the value of this one, shift this thing on the other side and subtract from there. Whatever your answer is, divide your answer by 0.20. You'll be getting the value of W. So I'm not going to show the baby steps here. You do the working by yourself. The value of W that you'll be getting in 2SF would be 15 newtons. So the working is shown over here, but I have written the answer over here.